So let's look at the last part. Find the exact area of S, meaning this S here. Okay, so we're going to find, I'm just label all the points here. Now it's very good. So this is -2. It's always good to just write down the parameter which correspond to each point first. So for example, we already find y equals 0, t is minus pi over 2 here. Right, so this is t equals pi minus pi over 2. This point here, this corresponding point here, t is minus pi over 2. Alright, so if we want, okay, very likely we need to find what was this t later, but we just try and see how do we find the exact area. Find exact area meaning we need to use use integral. We can't use calculator. So exact area of S, what we need is actually what I would suggest. We could use with respect to x here as well. So I just took this triangle here minus of this small triangle here. Okay, the one below here. So here I'm gonna just write this down. Here I'm gonna take this sort of this quadrant here. So I just take this quadrant and just copy this area here. Okay, so this quadrant here, maybe I should draw it nicely. Okay, so this quadrant here, copy it. This is what we need to find. Minus of the triangle here. Okay, so this case here is like that. All right, so what we're going to do here is going to just find out this is 0, and then after which this over here, this is a line equation. Just this will be y equals 0. I think very quickly we can find out what is this point here when y is 0. X is just -5/2, so this is -5/2. Okay, so let me just erase this away because we don't really need that now. Great. This area is negative area. Remember, this is below the x-axis, so you can just do this integral here. All right, you start off with this -2 here. We will start from we're gonna mod it actually. Just integrate from the smallest. So this over here, the x-axis here is we found just now -2√2. So we start from -2√2 to 2. -2 here. 2 to -2. So you start off with the smallest to the bigger value, and after which we're going to use this y dx, right? So it is y dx here. Okay, this y will just use the y of the curve here later. Okay, we're going to use the y of this curve here. Then we're going to use this triangle. This triangle is pretty simple. This triangle is just base times height. This height here is just 1 unit. This is just 5/2, just -2 minus 5/2. That will be half. Okay, so the length here is half. The height here is 1. All right. So just remember to mod this, because this we're going to use geometry to find this triangle. So this is just -half times half times 1. So if you're using integral, just make sure that this area below is a negative area. So you should know that to mod it. Okay. So what we're going to do next is this. We're going to change it to parametric form. So to change the parametric form, this is where this is important, because a lot of times students forget. Now, when this is x, this will be x equals to 2, this is x equals -half. So this now we need to change this to the parameter. Okay, so everything now we need to change the parameter. I think for the y is easy to change. The y, we're just going to copy the whole thing here. So cosine, what is that? Cosine, sine t plus cosine t. All right, so that will be sine t plus cosine t over 2. So sine t over 2 plus cosine t over 2 there. Then dx dt, we're just going to differentiate this. So dx dt just be 2 cosine. So this is half. Oh, very nice. Plus sine half as well, sine t over 2. So this will just be cosine t over 2 plus sine t over 2. Okay, so dx would then be cosine t over 2 plus sine t over 2. Now I know some schools wouldn't allow you to write this, but I don't really think it's an issue, because a lot of textbooks, I'm talking about university textbooks, we do write this down. But if you don't allow, then just don't write it, okay? So it's just make sure that you grade it out. If your school doesn't allow, I don't think, because in order to do the rest, it's gonna be, we need higher, like more advanced algebra to do it. So we're gonna look at dx. This will be cosine t over 2. Just make sure that we differentiate this correctly. So cosine, this is cosine t over 2, and that will be plus sine t over 2. Okay, and this is dt, right? Dx dt cosine, yeah, great. So now the problem is no longer the it is a parameter. So at x equals to negative 2 over root 2 here, we know that the parameter, corresponding parameter, is minus pi over 2. So that is pretty okay. Minus pi over 2 here. This parameter is the one which is a problem. So when x equals to minus 2, we know that this is minus 2 equals to 2 sine t over 2 minus cosine t over 2. Now this looks complicated. This one doesn't seem like we can solve this, because it's gonna take for a while. So I would suggest we use when y is equals to minus 1. Then when we use y, that will be minus 1 equals to sine t over 2 plus cosine t over 2. Suddenly we can just add them up. So just add them up, add both of them up, and we will get minus 2 plus equals to 2 sine t over 2. So sine t over 2 is just minus 1. Okay, now remember just now previously t over 2 is between minus 3 quarter, negative 3 quarter pi, and negative pi over 4. So we inverse this, you will get actually negative pi over 2. Okay, so you just use your calculator, you will get second inverse, negative 1. You can have negative 90 is negative pi over 2. So that is it. This is within the range, so t is actually minus pi. Alright, so in other words, this case here, this is actually minus pi. Let's take note of that. So there you go. We can. So now this area will give us negative area. So just make sure when you open up the modular sign, or if you don't want to open up modular sign, it's fine also, but this would just swap. Okay, because this we know will be a negative area. So this will be, I'm going to expand this sine square t over 2 plus 2 sine t over 2 cosine t over 2 plus sine cosine square t over 2 dt. It's 1/4. Okay, 1/4. Yeah, okay, great. So then this would just be 1. These both will add up to 1. Because cosine square a plus sine square a is 1. Right? This will just be 2 sine a cosine a equals to sine 2a. So when I change my equation here, what I'll get is minus pi over 2, 1 plus sine t. Wow, great. It looks good already. So this case will be just t minus cosine t minus pi over 2 minus pi minus 1/4. That will give us minus pi over 2 minus cosine minus pi over 2 minus pi. Moment of truth. cosine negative 90 will be 0. So that will be minus pi over 2 minus of cosine minus 180 will be negative 1. So this will just be, okay. So expand everything out. What we'll get is pi over 2 yeah. So yeah, it's a positive answer here. So this is square units. Yeah, I don't have the final answer here. So if you have any question or comment, please do let me know. It's a very interesting question. For this question is actually quite a long question here. Just make sure you're okay with most of the steps. All right. So any question, comments, please let me know, and I'll see you in the next question.